Problem 15. For how many numbers k, the following equation has no solution? Okay, so we have an equation x minus k over x minus 1 equals to x minus 1 over x minus 2. So we can use cross product to rewrite this equation. So cross product, let's review. A over B equals C over D. So we cross product. So we have AD equals BC then. So just like 1 over 3 equals equals 2 over 6. So we cross product. So 1 times 6 equals 2 times 3. Okay, so then we use cross product here. X minus k, x minus 2 should equal to x minus 1 squared. So let's expand this. So this is x squared minus 2x minus kx plus 2k should equal to x squared minus 2x plus 1. So we cross the same term. We'll cancel them. So negative kx should equal to 1 minus 2k. So x equals to a 2k minus 1 over k. Okay, so we solved x in terms of the k. So next step, we need to find out what value of the k where the letter x has no solution. So x equals 2k minus 1 over k. So first, of course, if k equals 0, x has no solution. The second, because x in here is denominator, x cannot equal to 1. So that means 2k minus 1 and the k if equals to 1, so x has no solution. Okay, so then we solve that is 2k minus 1 equals k, then k equals 1. Then k equals 1 has no solution. So number 3 also kx cannot equals to 2. So 2k minus 1 over k equals 2. So 2k minus 1 equals 2k. So for this equation, k itself has no solution, so we don't need to consider this choice. Okay, so we just have these two values, which is k equals 1 and the k equals 0 and k equals 1. So let's plug in quickly. Okay, so k equals 0, so x times minus 0, x minus 1 equals x minus 1, x minus 2. So x minus 1 equals x minus 1, x minus 2. So that's x squared minus 2x equals x squared minus 2x plus 1, right? Cross product. So of course, 0 equal 1, no solution. Okay, so we check it. Okay, so x equals 0 with the letter, k equals 0 with the letter x has no solution. So let's plug in k equal to 1. So then we have x minus 1, x minus 1, x minus 1, x minus 2. Obvious, x has no solution. So, okay. Then finally, we'll just have two values for k. K equals 0, k equals 1. Let x has no solution. So the answer is C. Problem 16. At the exit of the supermarket, 5 customers are ready to pay. There are 3 checkout counters. So if each counter needs to have at least 1 customer, in how many ways both counter selection and the paying order matter can they pay? Okay, so first we have 3 counter. Counter 1, counter 2, counter 3. Counter 3. So we need to determine how many customers in each counter. So let's say there's X customers in counter 1, Y counter 2, Z counter 3. So we have X greater equal to 1 because each counter needs to have at least one customer. So Y, Z all greater and equal to 1. And X plus Y plus Z equals 5. So how many ways? So let's recall there is a star and a bar solution for this. Okay, so these are 5 positions. So we can actually insert bars between these positions to split these 5 positions into 3 groups. So we only need to insert 2 bars. So these 4 positions, we just select 2 out. So it is 6 ways. Okay, so we got 6 ways first. And for each ways, we need to permute 5 customers. So that is 5 factorial. So times 6 ways. So 5 times 4 times 3 times 2 times 1, then times 6. That's equals to, okay, 20, 120 times 6, 720, which is D. Problem 17. Mr. Lee's class has 52 students. So I draw the Venn diagram here. So 30 of them can swim. 35 of them know how to ride bicycle, and 42 of them can play tennis. So what is the minimum number of students who can do all these 3 activities, which is the intersection of set S, B, T? So let's review the formula for the 2 sets intersect to each other. So A, so we have A union equals to set A plus set B, subtract set A intersect set B, the intersection of set A and B. So why we need to subtract this copy? Because when we add B and A and B, then we actually add this copy twice. We only need 1 copy, so we subtract 1 copy. So let's look at these 3 sets intersection to each other. So we have S union B union T equal to set S plus set B plus set T, and subtract to the intersection of S and B, and subtract S intersect T and the intersection of set T and B. And because we subtract intersection of BT, S, B and T, S and B, and T and B, then we actually subtract this intersection of S, B, and P, this section 3 times. And we just add 3 times from set A, set B, set T, so we need to add back S and B and T intersection of S and B and T. So then that one is our number of students who can do all these 3 activities. So then we have S intersect B and T equals 2. So we have S union B union T, which is 52. Then we subtract S, which is 30, subtract B, 35. So subtract the T, 42. Then we need to add S, the intersection S and B, the intersection S and T, and the intersection T and B. So if we can find the minimum number for these 3 sections, so then we can have the minimum number of S, the section S and B and T. So let's come back to calculate the minimum number for the two sets to intersect each other. So then we have S union B equals S plus B. Subtract S, the intersection S and B. So then intersection S and B equals to S union B. Equals to S plus B minus S union B. So as we know, S union B, the largest number is 52, so this is maximum 52, so then give this minimum. So then we have S is 30, B is 35, subtract the 52 equals 13. So that's the minimum number for S, this intersection with S and B. So we will have, okay, so let's do 52, subtract 107, and plus 13. And we use the same way, we can get it, okay. We can get the minimum for S, this intersection S and T equals 30 plus 42, subtract 52. So that's 20, and T and the B intersection equals 35, okay, plus 42 minus 52, so equals 25. Okay, so we add 20 and 25. So total would be equals to 3. Okay, so we got our answer is A, 3. Problem 18. ABCD is a trapezoid with the area of 432 and the AB parallel to CD. A circle of radius 9 is tangent to AB, BC, CD, and DA. If BC equals 22, so what is the length of the DA? Okay, so let's review the tangent line of a circle theorem. So if we have a point P, we draw two tangent lines, PA and PB, which AB is a tangent point to a circle. So let's prove PA equals to PV. So let's connect this center O of this circle to tangent point A and the tangent point B and the OP. So we have two triangles, APO and POB, okay? So these two triangles actually are congruent to each other because they have radius S, they have shared side, and they have this right triangle, which is congruent. They're equal to each other. So these two triangles, PAO is congruent to triangle PBO by SSA in the right triangle. So then we got the corresponding side, PA equals PB. Okay, so because these PA, if the point, one point outside the triangle, draw two tangent lines, these two tangent lines, the lengths, they're equal. So then we have A, we go to this tangent point. If we say the length is A, so then we have the same length here is A. And B, we have the length B here. And C, we have the length C here. And D, we have a length D here. Okay, so area of this trapezoid equals to 1/2 AB plus BCD and times height. So what is the height of this trapezoid? So if we connected O to the tangent point and this tangent point, okay, so these should be one line is because AB is parallel to CD, and this is 90 degree, 90 degree. So it's one line, also it's a height. So we know the radius is 9, so height is 18. So we have 1/2. Okay, so AB, which is A plus B, and plus CD is C plus D, and times 18. And if we reorganize A plus D and plus B plus C and times 18, so we can see actually this can convert it to dA. A plus D is dA, plus B plus C is a BC. So actually, in this trapezoid, we have this two sides, two opposite sides. The add these lengths should be equal to the other two sides, the sum of the other two sides. So it's AB plus CD, the length, equals to BC plus DA. Okay, so we times 18 equals 432. So we know BC is 22, so then we just plug it in, and the 9 DA plus 22 equals, this is 9. So we divide it by 9, 4, 3, 6, okay, 4, 8. So then dA equals 26. So which is E? Solution is E. Problem 19. How many integers n between 1 and 300 satisfy that greatest common divisor n and 30 equal to 1? So that means n and 30 are relative prime. So let's factor 30 first. So we prime factorize 30 equals 2 times 3 times 5. So that means n can't be multiples of 2, 3, 5. So let's count how many multiples of 2, 3, 5 between 1 to 300. Okay, so 1 to 300. So as we know, the multiple 2 and the multiple, if multiple 2 is set, we say is set A, multiple 3, we say is set B, and the multiple 5 is set C. So we have the formula is A union B union C equals to set A plus set B plus set C, and subtract A intersect B, intersection of also A with C and B with C. Because we subtracted the 2, 3 intersection, and with this copy, the intersection of A and A, B, and the C, we subtract 3 times, and we just add 3 times. So we need to add one more copy. So A intersection A, B, C. So put here. So then the multiples of 2, 3, 5 between 1 to 300. So let's count A first. So A is a multiple of 2. Between 1 to 300 is 150. Then B is a multiple okay, so B is a multiple of 3. So 100. So C is a multiple of 5, 60. And intersection A and B, so that means intersection, it will be multiple of 2 and 3, then will be multiple of 6. So, which is 50. So intersection part of A and the C, so would it be 10? Multiples of 10 is 30. And intersection B and the C, it is multiple of B and C, 15. 20. Okay, so A intersect B intersect C will be multiple of 230. Okay, so which is 10? We have 10. Okay, so the total multiples of 2 and 3 between 1 to 300 equals to 150 plus 100 plus 60 and minus 50 minus 30 minus 20 and the plus 10. So that equals 310 minus 100 plus 10 is 220. So total number between 1 to 300 is 300. So we subtract the multiples of 2, 3, 5. 320, 80. So the 80 numbers could be n are relatively prime with 30. The greatest common divisor equals to 1. So the answer is A. Problem 20. The integers 1, 2, 3 to 100 are written on the board. What is the smallest number of these integers that can be wiped off so that the product of the remaining integers ends in 2? Okay, so we have the integers 1, 2, 3 until to 100. So we need to wipe off some numbers, then we multiply by the remaining numbers, and to get the unit digits is 2, okay, ends in 2. So unit digits is 2. So the first we need to consider is multiple of 5. So if we have multiple of 5 or multiples of 5, so the unit digits will ends in, definitely ends in 0 and 5. So we need to wipe off all the multiples of 5, which are 5 until 100. So total 5, 10, to 100, total 20 numbers. Okay, so after we wipe off multiples of 5, so then we have integers 1, 2, 3, 4, 5, 6, 7, 8, and 9, and 11, 12, until 19, and 21 until 29, until 91, until 99. So we have so many integers on the board. And then let's figure out what is the unit digits if we multiply by these single digits. It's end in each number. Okay, so 1 times 2 times 3, 6. 4 times 6, 24. Then 4. 4 times 6 again. Then 4. 4 times 7, 28. Then 8. 8 times 8, 64. So 4 times 9 would ends in 6. So this would be same because they have the same unit digits. So ends in 6. So all ends in 6. So if we multiply by these numbers, so the unit digits would be 6 tenths. If you have the 6 perfect power, you always have unit digits is 6. So in order to get the unit digits is 2, so we need to wipe off one more numbers. So let's wipe off 3. So then this would be ends in 2. So then we have 2 times 6 power of 9. So this is unit digits, always 6. So 6 times 2. So that would be unit digit. Would be 2. So ends in 2. So total is 21 numbers we need to wipe off in order to get the remaining integer product ends in 2. Answer is B.